Let's continue our lecture video in integral calculus with the topic logarithmic function. Now the pattern that we are going to use here is the integral of du over u is equal to ln u plus c. Now let's use that by solving these exercises. Integrate the following and check by differentiation. Number 1, integral of 2 dy over 3y minus 4. Now this is also equal to 2 dy over 3y minus 4. Now if we try to use power formula here, so this is 3y minus 4 raised to negative 1 dy. So if we are going to use power formula, then we will let u is equal to 3y minus 4 du is equal to 3 dy. So insert in the pattern. So 2 is already there. Integral of 3y minus 4 raised to negative 1, then 3 dy. To balance, we need to put 1/3 here so that this one will be cancelled. That is equal to 2/3 of 3y minus 4 raised to negative 1 plus 1 all over negative 1 plus 1 plus c. Now this is not the solution because you will be getting the answer 3y minus 4 raised to 0 over 0 plus c. So we can't use power formula here. And we need to take note that the reason is if the denominator has a power of 1, only 1, if you put it in the denominator, if you put it in the numerator, it becomes negative 1, and later on, it will be added with 1. The answer will be 0 always. So that's why it is good to note that if the denominator, the power of the denominator is 1, then it is time to use the logarithmic function. Why? Well, let's try to use it. For logarithmic function, this is the pattern. So for u, so let u here, we'll let u, whatever is in the denominator, and always make sure that the denominator has a power of 1. So derivative of u is equal to 3 dy. Then use this pattern. So we have there 2 integral of the du here is 3 dy all over the u is 3y minus 4. Now since the original here has no 3 here, therefore we will put 1/3 outside the integral sign so that it could cancel out the 3. Okay, and disregard this portion here. Therefore we now have 2/3. Now the pattern for the answer is ln u plus c. So that is ln of u, which is 3y minus 4 plus c. So this is the answer. Checking here is the derivative of the answer 2/3 ln of 3y minus 4 plus c, that is equal to 2/3. Derivative of ln of u is equal to derivative of what is inside is being put in the numerator. So that is 3 minus 0 all over the u, which is 3y minus 4. Then derivative of constant 0. So the final answer is 2/3 3 over 3y minus 4. That is equal to 2 over 3y minus 4. Same with the given. That means this answer here is correct. Now, what have we learned from the example number 1? Again, we need to take note. For us to use the logarithmic function, the power of the denominator should not be greater than 1. Or that for us to use this logarithmic function, the power of the denominator should be 1. Okay? You can reword that. Power of the denominator should be 1. So that is for the example number 1. For number 2, integral of 1 minus 2x squared all over x dx. So the power for x here is 1. Now let's see if we can use the logarithmic function here. So that is equal to, let's expand the one in the numerator. We have there 1 minus 4x plus 4x squared dx all over x. Then we can distribute dx over x minus 4x over x dx plus 4x squared over x dx. That is equal to integral of dx over x minus 4 integral of dx plus 4x dx. Okay. So for the first term here, we can notice that x has a power of 1. So let u is equal to x, du is equal to dx. So can we use the logarithmic function here, formula? So let's have the pattern here first. Integral of the du, which is the dx, and the u, which is the x. So similar. Then for this part here, that's already 4x. 4 integral of dx is 4x plus this one here is 4x raised to 1 plus 1 over 1 plus 1. No plus c yet because of the presence of the integral sign. Okay, that is equal to ln of x minus 4x plus 4x squared over 2 plus c. That is equal to ln of x minus 4x plus 2x squared plus c. Okay, that is the answer. Now for the checking by differentiation, so let's derive the answer, which is the ln of x minus 4x plus 2x squared plus c. So this is, the ln of x is 1 over x minus 4x1 minus 1 plus 2 times 2 x2 minus 1 plus derivative of constant 0. So that is now equal to 1 over x minus 4x raised to 0 is 4 plus 4x, and if we put here the denominator x, this is 1 minus 4x plus 4x squared. So this is similar to the given. Therefore, the answer here is correct. Now for number 3, the integral of v plus 3 over v minus 1 dv. How do we solve this? Well, they both have a power of 1. So if we let u here equals v minus 1, du is equal to dv. So what happens here? So no, we cannot use the the logarithmic function yet. So what should we do first? Now we can divide this. So if the power here is greater or equal to the power in the denominator, we can divide it. So let's do some division. V plus 3 divided by v minus 1. So that is, put 1 here. So 1 times v minus 1. So this is minus. This becomes plus. So this is 0. Then this is bring down 4. Positive 4. So we can just remove here the 0. So since there's nothing to bring down here, so let's have the remainder 4 over v minus 1. Okay? So this is similar with 1 plus 4 over v minus 1 dv. So let's try to use the pattern for logarithmic. And we use that here. So distribute, this is integral of dv plus 4 integral of dv over v minus 1. Let u is equal to v minus 1. du is equal to dv. So if that happens, then we can now have here, this is integral of dv, this becomes v plus 4 ln of u. The u here is b minus 1 plus c. So this is now the answer. Now checking, let's do some checking here by differentiation. Derivative of the answer, which is b plus 4 ln of v minus 1 plus c, that is equal to, derivative of v is 1 plus 4, the derivative of ln v minus 1 is, derivative of v minus 1 is 1 over v minus 1 plus derivative of c or constant is 0. It's now equal to 1 plus 4 v minus 1. And this is equal to v minus 1 plus 4 v plus 3 over b minus 1. So the same with the given, therefore the answer here is correct. So that's for number 3. So the trick here that we did is we divided the numerator from the denominator. How about number 4? What trick can we do here? So integral of tangent x dx. Do we have an integral for tangent x in the previous video for the trigonometric? None. There's no integral for tangent x dx from the trigonometric formulas. Therefore, we need to do something here in order for us to be able to integrate tangent x dx. And one way is having tangent x converted into sine x dx all over cosine x. So let's see if we can solve this by using powers. Power formula, we have there cosine x raised to negative 1 sine x dx. So this is now equal to, so let u is equal to cosine x, du is equal to negative sine x dx. Okay, so substitution, we have there cosine x, negative 1, negative sine dx, sine x dx for the du. Compensate with the negative sign. What happens? Disregard. Negative cosine x raised to negative 1 plus 1 over negative 1 plus 1 plus c. What happens here is it becomes negative cosine x raised to 0 over 0 plus c. No, we cannot use power formula. Again, even though it's a trigonometric function, we cannot use the power formula because the denominator has a power of 1. So the method here to solve, the method that can help solve this is by logarithmic formula. Okay, so let's try that. So since the power here is 1, we will be using the logarithmic formula. So let u is equal to cosine x, du becomes negative sine x dx. Follow the pattern. So we have there integral of du, which is the negative sine x dx, all over the u, which is cosine x. And since from the given here there's no negative sign, we put a negative sign outside. Then disregard this portion here. Therefore, the answer becomes, if we satisfy this pattern, therefore the pattern for the answer is ln u plus c. So negative ln of u plus c. So checking, by differentiation, we derive the answer. Negative ln of cosine x plus c, that is equal to negative derivative of the u. Derivative of cosine x is negative sine x, copy u, plus derivative of c is 0. So the final answer here is sine x over cosine x, or that is tangent x, which is similar with the given. that's the case, then the answer here is, again, correct. Okay, so that is for number 4.